Hello everyone, confusing to hear an unfamiliar voice?
Today, the students take over. I'm Shreyas.
And I'm Puja, and we're
And we are
here to teach you about Q learning, a unique approach towards learning reinforcement techniques.
Puja, have you ever wondered topics like these seem to be very complicated in theory?
Well, there are practical applications to this in recent technological advancements, most prominently in AI concepts like NLP or natural language processing and game theory. Do you know how Q learning is the most efficient form of reinforcement learning?
Wait, really? How?
Don't you think people should know what Q learning really is before we start talking so it doesn't sound like Greek and Latin to them?
Good idea. But Puja, do you remember what Q learning is, or do I need to tell everyone?
I'm good, Shreyas. Formally speaking, Q learning is a value-based off-policy temporal difference reinforcement learning technique. Off-policy means that the agent makes use of different policies within the environment other than the policy that is currently being implemented, called the behavior policy, to determine the best course forward to reach the goal state. This means that from the next state, another policy is also being explored along with the behavior policy. There are different components of Q learning. First, state. The state represents the current situation or the configuration of the agent and the environment. One environment can have multiple states, each state mapping to the other and reaching the goal state brings together a policy. Second, action. It refers to all the possible moves and decisions that the agent can make to transition from a given state to the next. An action is deemed very important in reinforcement learning as mapping of the transition of the states through actions determines the policy that will be taken into consideration when an optimal policy is being devised. Third, reward. Reward is the immediate feedback or reinforcement that the agent receives after taking an action in a particular state. The feedback received after transition to the next action is either positive or negative. Positive when the agent makes a move towards the goal state, and negative when it does not benefit from the agent in terms of reaching the goal state.
So it's all mathematical. But then again, everything AI is mathematical. How does it work?
To be precise, Q learning revolves around Q values being updated at every action of the agent so that the highest value represents the best action forward.
So that means state represents the current situation or configuration, action refers to the possible moves or decisions an agent can take, and reward is the immediate feedback that the agent receives. With this, we can build the Q formula. Q of S, A equals Q of S, A plus alpha star R plus gamma star max of Q of S dash A dash minus Q of S, A, where Q of S, A represents Q of present state action pair and Q of S dash, A dash represents Q of future state action pair. And alpha represents the learning rate, gamma represents the discount factor.
So here's how Q learning on the face of it works. First, a Q table is initialized so that the Q values of every state action pair can be kept track of. Second, since the agent has not made any moves, initially all the values are 0, and upon using different exploration strategies, the values for different components for the determination of the Q value are found, making the Q value updation easier. Third, upon completion of an exploration, the agent analyzes the table and the maximum value to choose that pair as a part of the optimal policy.
So let's talk about the math behind this. As discussed earlier, Q values are to be determined to be able to add the Q values to the Q table. This means that the Bellman equation is used to find the Q value. The formula looks like Q of S, A equals E of R subscript T plus 1 plus gamma max Q of S dash, A dash. As far as updating the Q value is concerned, we use the previously determined Q value and the expected reward for the next state to find the Q value and continue updating the Q table. The updation rule looks like Q new of S, A equals 1 minus alpha of Q of S, A plus alpha of R subscript T plus 1 plus gamma max Q of S dash, A dash. These values determine the best action and policies. And then, of course, the highest value is the action most suitable for the environment.
So now all these values, but no place to organize. That's where the Q table comes in. The Q table consists of different states within the environment and also different actions that can be taken to reach our goal state. Each state has its own value, and this value is used to determine the Q value of the particular action. The Q value of the particular action in every state is compared with each other, and upon determining the highest value, The state with the highest Q value of that action is chosen in the optimal policy. This is how a Q table works.
That's right.
We previously discussed AI techniques integrating Q learning as a practical application, right? Can you tell me how that goes about?
You sound like the Dora the Explorer. Let me explain it. It optimizes a task like text generation and dialogue systems by treating them as a sequential decision making problems. It starts by defining states, which represents the current text or dialogue context, and actions, which involve selecting the next word or response. Rewards are based on the quality metrics such as coherence, relevance, and user satisfaction. Through iterative updates of Q values based on these rewards, the model learns an optimal policy, continually refining its ability to generate high quality, contextually appropriate outputs. This method significantly enhances the performance of NLP systems, leading to more intelligent and responsive applications.
Any other applications you can think of, maybe?
Well, I can think of web system configurations. You know, there are four categories of features: user feature, context feature as a state features of environment, user news features, and at last the news features as the action features. These features are the input to deep Q network to calculate the Q value.
Great job, Shreyas. I'm almost proud of you.
What can I say? You learn every day.
Well, Shreyas, since we learned something new today, please brief us on that.
We learned about the basics of Q learning, their components like state, action, and reward, how the values are calculated with Bellman's equation reaching an optimal policy. And we found that Q learning is used in multiple applications like in web configurations, and how the four features were input to the deep Q network to calculate the Q value. And in NLP, it optimizes tasks like text generation and dialogue systems by treating them as sequential decision making problems.
Awesome. That brings us to the end of today's video. Stay tuned for more, everyone.